right, so we're trying to prove here that for a finite group, every element has a finite order. So let's start with what we know about a finite group. We know that a finite group, G star, we know that G is going to be closed. We know that the inverse element exists, the identity element exists, as does the inverse. For A element of G, A inverse exists. And we also know that it's has the property of associativity. I'm not sure that that's going to help us. And now we're trying to show that every element has a finite order. Well, let's assume, again, proof by contradiction, that every element does not have a finite order. Yeah? But let's start with listing our elements. So our elements, we could say that G, definitely it has the identity element. Maybe it has something order 1, order 2, order 3. And let's say that we go up to order of n. But notice, this is going to be n plus 1 elements. Yeah? That means, this is n plus 1 elements. That means one of the elements must be repeated because we know we have a closed group, so it means we've written one more than one time. Yeah? So this element of n, that's what we're trying to show, that it has to be finite. So basically what we've said is that there's two elements in here that must be equal to each other. So a to the I must be equal to a to the j. But we know that the inverse exists. Yeah? So we can apply left cancellation, right cancellation, a to the I star a to j inverse, a to the j star a to the inverse. I don't know if I wrote down our notation for inverse. Inverse, yeah? Not 1 over a to the j. All right? So this is going to equal our identity element. And this is going to equal a to the I minus j power. Well, we know that I minus j is a finite number. Yeah? So that means that we've got every element must have a finite order. Yeah? I minus j is finite. And further, we know that it's less than n. So we have that every element in a group is going to have an order less than or equal to the order of the group. Yeah, it's pretty key there. I'm going to write that down. So every element of a group has an order less than or equal to the order of the group. And that's something that we're going to see over and over again. So just to emphasize it.